Hello everyone, welcome to MathWorld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 6, which is the Probability and Statistics 2 for October-November 2021, and the code is 9709/61. So for your information, this paper is same as 9709/63. Okay, so it is the same content of papers. So let's move on to question number 1. Now for question number 1, it is known that the height in meters of trees of a certain kind has a distribution normally distributed. 12.5 is the mean and the variance is 10.24. A scientist takes a random sample of 25 trees of this kind and finds its sample mean h bar of the heights. A. State the distribution of h bar giving the values of any parameters. So basically h bar is normally distributed with mean 12.5 and now the variance becomes 10.24 over 25. Okay, so that is going to be normally distributed with mean 12.5 and then the variance is 0.4096. So that is the distribution of h bar. Okay, so for question number 2, find probability that h bar is between 12 and 13. So for your information, if let's say your x is normally distributed with mu and sigma squared, okay, so the z is x minus mu over sigma. But now if let's say it is x bar, then here over n, this is going to be over square root n. Okay, so you can change this into square root of sigma squared over n as well. That is the standard deviation. Right, so from here I would say my just now h bar is n distributed or normally distributed 12.5 and variance 0.4096, and then now the probability that h bar is between 12 and 13. So now we need to standardize it using this formula. Okay, so p 12 minus 12.5 over square root of 0.4096 is less than z less than 13 minus 12.5 over square root of 0.4096. Then when you calculate these two values, that is going to be negative 0.781 and positive 0.781. So after this step, the next step is supposed to be graph. So here I simply sketch a graph. It is a symmetrical graph, middle is 0, and two symmetrical lines, negative 0.781 together with 0.781. So since it is in between, so that means the region is bounded by the two lines. So now, to get this probability, I will say that the left-hand region, this part from 0 to negative 0.781 can be reflected to the positive part. That means it's basically double of the orange color. Okay, that is our probability. So I will write this is double of probability, the z between 0 and 0.781. So now to get this probability, since your table only gives you the probability from the positive line towards a negative infinity, so I'm going to use this probability, which is pz less than 0.781 minus pz less than 0. Okay, so that is going to be double of pz less than 0.781 minus pz less than 0. Then this is going to be double of, now the first probability that you can get from the table is 0.7826. And then pz less than 0, that means this is half of the graph, therefore it is 0.5. So at last, you will be getting 0.5652, and now round up the answer to three significant figures, that is going to be 0.565. So that's the solution of this question. Okay, so for question number 2, the number of enquiries received per day as a customer service desk has a Poisson distribution with mean 45.2. If more than 60 enquiries are received in a day, the customer service desk cannot deal with them all. Use a suitable approximating distribution to find the probability that on a randomly chosen day, the customer service desk cannot deal with all the enquiries, which means it is more than 60 enquiries. Okay, so your lambda is 45.2. This is per day. Alright, so since it is greater than 15, therefore we need to use normal approximation. So instead of solving using Poisson distribution, now we need to change to normal distribution, which means now your x is Poisson distributed with 45.2, and when I change to normal distribution, I will use another variable, which is the w, and then it's normally distributed. The mean and variance for Poisson will be the same. Therefore, for the normal distribution, the mean will be variance. The mean will be same as the variance. Okay, so now it's mentioned that more than 60 enquiries then cannot deal. Therefore, you need to calculate what is the probability that x is greater than 60. So when x is greater than 60, now your x is Poisson distributed. That means this is discrete. Okay, but then the normal is continuous. So when discrete approximate to continuous, that means you need to consider the correction factor, continuity correction factor. That is to consider whether you plus or minus 0.5 from this value. So here is 60, but then we know that greater than 60 means it will be 61, 62, and so on. Okay, and now you have two choices. The choices will be either you minus 0.5 from 60 or you plus 0.5 from 60. So here will be 59.5 because you minus 0.5 from 60, or you plus 0.5 from 60, that is 60.5. And now when you convert, we change the x into w, remain the sign, which is more than, and now obviously I need to choose more than 60.5 to include the two ticks. So here will be greater than 60.5. Alright, so then now when it is normally distributed, x is normally distributed with mean mu, variance sigma squared. We need to standardize it. So z equals to x minus mu over sigma. Therefore now here you will be getting b z more than 60.5 minus the mean is 45.2, then variance is 45.2. That means the standard deviation will be square root of the variance. Then from here, you will be getting the value of BZ more than 2.276. Okay, then now, right after this, it will be the graph. The graph is symmetrical at origin. Then the value is 2.276. Therefore, it is on the right side. And now, because of more than here, the region is towards right side. So, now, the table only shows you the region towards left side from the positive line. Okay, which means table shows you the yellow value, right? The yellow region. So which means to get this, I will just use the concept total probabilities minus the yellow region. So total probabilities is 1. Therefore, 1 minus b, z less than 2.276. And this is going to be 1 minus 0.9886. And at last, you will be getting 0.0114, which is correct to 3 significant figures. Okay, now next question number 3. A random sample of 75 students at a large college was selected for a survey. 15 of these students said that they own a car. From this result, an approximate alpha % confidence interval for the proportion of all students at the college who own a car was calculated. The width of this interval was found to be 0.162. Now calculate the value of alpha correct to 2 significant figures. So from here, since it is proportion, right? So now P hat, the number of successors will be 15 out of 75. So 15 over 75. Then you are getting 1 over 5. Now our Q hat is 1 minus P hat, which is 1 minus 1 over 5. Then you will be getting 4 over 5. Now, for your information, the width is 2z, okay, 2z square root of P hat Q hat over N. This is the width formula. So 2. Now, the width, the z, we do not know. That's why you need to find what is the alpha here. This is supposed to be alpha over 2. Okay, alpha over 2. Then square root of P hat is 1 over 5, Q hat 4 over 5, and the N is 75. Now our width is given 0.6162. So then from here, I will say that 0.162 equals to z alpha over 2. Then when you calculate all these three values, right, all these values, so for information, this includes 75, then you will be getting 4 square root 3 over 75. Now, from here, I will get my z value. Z value will be 0.162 divided by 4 square root 3 over 75. That means you will be getting the value of 1.7537. But then the table only shows you 3 decimal places for the z. Therefore, it will be 1.754. Okay, so now, after this, we need to refer to the graph. So, for information, the middle value is 0. So, when 1.754, okay, all these regions, it will be 0.9603. So, from table, PZ less than 1.754 is 0.9603. But then we need to find out the alpha value for the confidence interval. So we know that confidence interval is symmetrical. It's a symmetric confidence interval, which means I need to find out, okay, here. This will be my alpha percent. Okay, so now I need to find out what is this. Okay, so obviously it will be 1 minus 0.9603. So here, probability that z more than 1.754, that is 1 minus 0.9603. That is going to be 0.0397. So I know that, right? The region on the right side now, 0.0397, which means these two regions are symmetrical. Therefore, here is 0.0397. So the blue region is 0.9603. So this blue region including this orange region, which means now my alpha region is just to minus both regions here. So now my alpha percent will be 0.9603 minus 0.0397, and to get percentage, just times 100%. That is going to be the middle region, which is 92.06%. And now if you round up, okay, when you consider the percentage, so here I will just write 92.1%. So therefore my alpha is 92.1. Okay, let me double check first. Okay, then now look at the answer, the question here. 2 significant figures is no longer 3 significant figures. So now if 2 significant figures, I shouldn't write 0.1. Okay, so it will be just 92%. Okay, therefore you will be getting 92 for the alpha value. That is my 2 significant figures. Okay, now next question number 4. A random variable x has a probability density function given by this. So fx is 1 over 18 times 9 minus x squared when the x is defined from 0 to 3, and otherwise means other x values, fx is equals to 0. Now calculate this probability. X is less than 1.2. So for the calculation of the probability is basically you integrate, right? So px less than 1.2, and since your x starting from 0, that means now I will integrate from 0 to 1.2. So of the fx, therefore 1 over 18 times 9 minus x squared dx. Then from here, for the integration, since 1 over 18 multiplied with the quadratic function, I will just factorize a constant before I do integration. Now, for you to integrate, so integrate x degree n dx, that is going to be x degree n plus 1 over n plus 1, then plus c. With limits, then no need to plus c. That means now here is going to be 1 over 18. So integrate 9x, then the x squared becomes x cubed over 3. And limits will be from 0 to 1.2. Then now from here, just replace the x by 1.2 first, then followed by 0. Okay, so I will get 1 over 18, 9 times 1.2 minus 1.3 times 1.2 cubed, and minus the rest. Then here it will be 71 over 125, and at last you will be getting 0.568. So that's the probability of part A. Now B, find EX. EX is the expected X. So EX is found using integrate X fx. And now you need to integrate for the whole X values, means that from 0 to 3. So here I will write 0 to 3, 1 over 18, X. Okay, I will write X first, because X times fx. So X, 1 over 18, then 9 minus x squared dx. And now the 1 over 18 can be taken out. So 1 over 18, integrate 0 to 3. Then this x, right, you multiply into the bracket. That means you will be getting 9x minus x cubed. So this is going to be 1 over 18. When you integrate 9x, it will be 9x squared over 2. Then the x degree 3 is x degree 4 over 4. And limits 0 to 3. Then now here I will be getting 1 over 18, 9 over 2, 3 squared minus 1 over 4 times 3 degree 4, then minus 0. Because when you replace the x by 0, everything is 0. Then this will be 4 over 8. Oh, sorry, it's 9 over 8. So the answer is 9 over 8. Okay, so done for the EX. Now the median of x is m. The median means that it is from the lowest x until the m, the probability is half. Okay, so you need to show this quadratic, this cubic equation. So I will write px from 0 to m, it will be half. That is the median, right? So integrate from 0 to m, fx dx equals to half. Therefore 1 over 18, integrate from 0 to m, right? So 9 minus x squared dx is half. Then I'll just replace accordingly. We have done this integration in the part 1. So this is 9x minus x cubed over 3, 0 to m equals to half. Then I'll just replace the x by m first. So I will get 1 over 18, 9m minus m cubed over 3, and minus when the x is replaced by 0. And now here we need to prove the equation in terms of m. Right? So what to do is, since you have here 3 and 18, so we know that 18 times 3 is basically 54. So I can just eliminate this this denominator by multiplying 54 to the whole equation. So it means that now I got to times, when you times 1 over 18 by 54 is basically 3. Okay, so the 3 you times by the 9, that means you will be getting 27m. But then for the second term, it will be cancelled off. So you will be getting negative m cubed, that m cubed, sorry. And then for the right side, for the right hand side, half times 54 is basically 27. Okay, so now I just need to rearrange to get m cubed as a subject. So I will move all the terms from the left side to the right side. So just move, then you will be getting m cubed minus 27m plus 27 equals to 0. So with this, we have shown the equation. Now, 5a, the proportion of people having a particular medical condition is 1 in 100,000. A random sample of 2,500 people is obtained. The number of people in the sample having the condition is denoted by X. Now, first part, state with a justification a suitable approximating distribution for X giving the values of any parameters. So from here, okay, basically when you refer to the people, right, it should be binomial. Okay, so from here I will write X is binomial distributed 2,500, and then the probability is 1 over 100,000. But from here, because your n is large, which is 2,500, that is more than 50, and then the NP, it is 2,500 times 1 over 100,000. This is going to be 1 over 40. So this 1 over 40 equals to 0.025, which is less than 5. Okay, therefore, that is Poisson distribution. So from here, I will say Poisson approximation. This is Poisson approximation to binomial. That's why in the question is mentioned suitable approximating distribution. Right? So now you need to write down what is the distribution. So which means now here I will say y is Poisson distributed with mean 0.025. Okay, so the justification is basically these two parts. Okay, now part 2, use the approximating distribution to calculate px greater than 0. So we know that, right? Probably here I do not use y, I will just use x because the question asking for x. Okay, so now here px greater than 0, that means this is going to be 1 minus px equals to 0. So for your information, if your x is Poisson distributed with lambda, so probability of x equals to small x or small letter x, lowercase letter x, it will be e minus lambda x over x factorial, and then your x starting from 0 until infinity. So since here is greater than 0, we do not know when to stop, so that's why we use a complementation rule, which is 1 minus the previous value. So greater than 0 means start from 1. So I minus when the probability x equals to 0. That means now here 1 minus e negative 0.025 because of this distribution, then 0.025 degrees 0 over 0 factorial. So this is basically 1. Okay, here is 1, this is also 1. So basically you can just write it is 1 minus e negative 0.025 as you're working, and this is going to be 0.0247. So that is the probability for part 2. Now part B, the percentage of people having a different medical condition is thought to be 30%. A researcher suspects that the true percentage is less than 30%. In a medical trial, a a random sample of 28 people was selected and 4 people were found to have this condition. Use a binomial distribution to test the researcher's suspicion at 2% significance level. So this is the hypothesis testing. Okay, so it's given H naught, P is 30%, but the researcher suspecting less than 30%. So that is the H1. Right? Then 2% significance level, 0.02 for your alpha. And now from here, okay, I will write reject H naught if, because here 4 people, so P x less equals to 4. Why less equals to 4? Because of less, right? That's why here less. Alright, so here is always less than 0.02. So this property is actually the p-value. So we always reject H naught when the p-value is less than alpha. Then now, before I calculate, I will write down my distribution first. So basically it is 28 for the n because of 28 people. Okay, and this distribution is a distribution when the H naught is true, which means the p is 0.3. Now, when it is binomial distributed with NP, n is the number of trials and the p is the probability of success, probability of x equals to x, that is ncx, px, qn minus x. That means now here we need to calculate this probability, which is px less equals to 4. So when px less equals to 4, remember, for the binomial, your x start from 0 until n. Therefore, now I have to calculate the properties of px equals to 0 until 4. Okay, so now just apply this formula. It will be 28C0. So basically when px equals to 0 means that no success. So if no success, that means all failures. Then from here I will write n equals to 28, p is 0.3, then a q is a failure rate, which is 1 minus 0.3, that is 0.7. So no success means all failures, 0.7 to the power of 28. Followed by 28C1, 1 success, 0.3 degree 1, 0.7 degree 27, plus 28C2, 0.3 squared, 0.7 degree 26. That is the px equals to 2. And now followed by px equals to 3, it will be 8C3, 0.3 cube, 0.7 degree 28 minus 3 is 25. Then plus 28C4, 0.3 degree 4, then 0.7 degree 24. Okay, so for each of these I will calculate. So it will be 4.59987 times 10 power negative 5 for the first value. Second value is 5.51984 times 10 power negative 4. And then the third value is 3.19362 times 10 power negative 3 plus 0.011862. Last value will be 0.031773. So here, as the working, I give more decimal places or more significant figures. Okay, so when you add up all these values, you will be getting 0.04743. So when I round up to 3 significant figures, that is going to be 0.0474. And now you compare with the alpha value. Look at here. The alpha value is 0.02. Right? So obviously it is greater than 0.02. So when greater than 0.02 means that by referring to this rejection criteria, we do not reject H naught. Okay, so here you just write since px at least 4 px at most 4, it is greater than 0.02, therefore do not reject H0. This is our decision. Okay, now for the conclusion, refer to the sentence here. Okay, so you want to test the suspicion, right? So since we do not reject H0 means that the H1 is not correct. Okay, so therefore there is insufficient evidence to support the researcher's suspicion. Okay, so this is the conclusion of the hypothesis testing. Alright, so let's move on to next question. Number 6. The random variable t denotes the time in seconds for 100-meter races run by Tanya. T is normally distributed with mean mu and variance sigma squared. Random sample of 40 races run by Tanya gave the following results. Calculate unbiased estimates of mu and sigma squared. So now, basically, unbiased estimate for mu, that is summation t over n. So summation t is 560. The n is 40 because 40 races. That is going to be 14. Okay, and then followed by unbiased estimates for the variance. This is 1 over n minus 1 multiplied with summation t squared minus square of the summation t over n. So this is going to be 1 over, your n is 40, so n minus 1 becomes 39, multiplied with 7850, which is given, minus square of 560 over 40. Then this is going to be 10 over 39. And you can just leave your answer correct to 3 significant figures. That is 0.256. So that is our working of this question. Okay, now the random variable S denotes the time in seconds for 100 meters races run by Suki. S has the independence distribution, which is normally distributed with mean 14.2 and variance 0.3. B. Using your answers to part A, find the probability that in the randomly chosen 100 meters race, Suki's time will be at least 0.1 second more than Tanya's time. Okay, so now I will write down T is normally distributed. So refer back to previous. So now the mean is 14. Standard variance is 0.256. So I will write 14, 0.256. And then for Suki's distribution, that is 14.2 and 0.3. Okay, now you need to calculate the probability. It will be at least 0.1 seconds more than Tanya's time. Okay, that means now you need to calculate P, Suki's minus Tanya at least 0.1, which means I need to find out the distribution of S minus T now. Okay, so since your S and T are normally distributed, that means the S minus T also normally distributed. So now I need to find out the expected value of S minus T. This is ES minus ET. That is going to be 14.2 minus 14, and you will get 0.2. But then for the variance S minus T, this is variance S plus variance T. Okay, so variance S is 0.3, then variance T is 0.256. So this is going to be 0.556. So which means, right, your S minus T is basically normally distributed with mean 0.2 and the variance is 0.556. And now here, since it is normally distributed, then we have to standardize it. So now, when I standardize, I will write Z more than 0.1 minus the mean, which is 0.2, over square root of 0.556. Then here is going to be P, Z more than negative 0.134. So now, right after this step, I will sketch a graph. The bell-shaped curve. So mark negative 0.134, and since this is greater than here, that means the region is towards right side. But then this region is not available. What I need to do is I just flip it, reflect. Okay, because the negative line is not available. The negative z value is not available in the table. So when I flip at the origin, it will be 0.134, and the region will be the orange region. So this region is available in the table, which means now by using the graph, I know that the probability of z more than negative 0.134 is basically same as probability of z less than 0.134. And this probability you can just easily find from the table. That is going to be 0.5533. And now I round up to 3 significant figures to get 0.553. So done for this question. Okay, next question number 7. The masses in grams of apples from a certain farm have mean, meal, and standard deviation 5.2. The farmer says that the value of meal is 64.6. A quality control inspector claims that this meal is actually less than 64.6. In order to test his claim, he chooses a random sample of 100 apples from the farm. Now A, the mean mass of 100 apples is found to be 63.5 grams. Carry out the test at 2.5% significant level. So this is hypothesis testing regarding the population mean. So now our H naught is mu equals to 64.6. But the quality control inspector says that it is actually less. So this less will be shown on the H1, that is mu less than 64.6. So your alpha is 2.5%, it will be 0.025. Okay, and now from here, now when you look at the question, it's mentioned that mean is mu. Standard deviation is given. So whenever standard deviation is given means that it will be normally distributed, right? So when normally distributed, so then we will be using normal table. So I will sketch a graph to decide the rejection region. Now, by looking at the H1, which is less than, that means it is the lower tail test. So your critical region or rejection region is on the left side. And then the probability is 0.025, which is from the alpha. But then when you refer to the table, the region is not available because the critical value, this straight line, the z value is negative. So what I need to do here is I will just flip this region to the right side, and I know that the region towards the right side will be 0.025. And then if the right side region is 0.025, that means the region towards the left side will be 1 minus 0.025. That is going to be 0.975. So with this 0.975, I can read the z value from table. That is going to be 1.96. Okay, but then this is not my actual region. That's why I will label negative 1.96. Okay, this is orange color. So orange color is not my actual region. Therefore, with this, I can write down my rejection criteria. That means reject H naught if Z is less than negative 1.96. Okay, the shaded region will be the rejection region. And now I will just show side by side because you are using 100 apples. Okay, that is your sample. Therefore, we will be using Z equals to minus mu over, the X bar minus mu over sigma over square root n for the calculation. So your X bar, read the question first, mean mass of 100 apples. This is X bar. So I will get 63.5 minus the mu. Mu is the value at the H naught, which means 64.6 over sigma is given in the question 52. This is sigma. 5.2, not 52. 5.2 over square root of 100. That means here is going to be negative 2.115. So when you get this value, just mark it on the graph. Negative 2.115 is in the region. Okay, therefore my conclusion is, or my decision is, since the Z is less than negative 1.96, so therefore refer to this criteria, we are going to reject H naught. So reject H naught. Now the conclusion is based on the question. Okay, so the inspector claims that the mu is less than 64.6. So now since we have rejected the H naught, that means there is sufficient evidence to support the claims, right? So you can just write there is sufficient evidence to conclude that mu is less than 64.6. Okay, so that is the solution for 7A. Okay, now for part B. Later, another test of the same hypothesis at 2.5% significant level with another random sample of 100 apples from the same farm is carried out. Given that the value of mu is in fact 62.7, calculate the probability of type 2 error. So now, P type 2 error is defined as probability of do not reject H naught, given that H naught is false. Okay, so from here, you need to calculate do not reject H naught. So now I need to find out in what condition we do not reject H naught. So then from the previous part, right, from previous parts we know that we reject H naught. Look at here, we reject H naught when the Z less than negative 1.96. But what about the region? Region means the X bar. Okay, so now I need to continue from here, from A okay, reject H naught if the Z is less than negative 1.96. So now I let X bar, or let rejection region, be X bar less than A. Okay, so now I need to find out what is my A now. Alright, so Z equals to X bar minus mu over sigma over square root n. So the Z is negative 1.96. This is a critical value when we reject the H naught. Then your X bar is replaced by A. then minus the mu is 64.4, 64.6. Refer to here, 64.6. Over standard deviation is given in the previous question, which is 5.2. Okay, over square root 100. Then now here you are expected to get the A, which is the rejection region. So now negative my A is okay, negative 1.96 multiplied with 5.2 over square root 100 equals to A minus 64.6. So to get the A, I will just move this negative 64.6 to the left side. And I will rewrite my A on the left side. It will be 64.6 minus 1.96 times 5.2 over 10. Because square root 100 is 10. Then from here, you will be getting 63.5808. Okay, so from here, I know that in the first part, actually we reject H naught if x bar less than this A value. Alright, so now to calculate the type 2 error. So look at here, when we reject H naught means that x bar less than that. So now P type 2 error, we do not reject H naught. Given that H naught is false. So when less than 63.5808 you reject, that means this is your value, 63.5808. Less than that you reject H naught. So if do not reject H naught, definitely it will be more than that. So this is do not reject. Okay, so from here, I will say that P x bar is greater than 63.5808. So I will not write the equal sign because your x bar is normally distributed. So it is continuous function, continuous distribution. Equal or not equal is not important. Now given H naught is false. So when H naught is false, now I need to write down what is my H naught then. Okay, which means I cannot accept the mu value as 64.6 because this H naught is false, right? So now that's why you are given the actual mu is 62.7, which is less than 64.4 or 64.6. So here I will write down the mean is actually 62.7, but then the variance remain, which is 5.2 squared over square root of 100. Okay, because your 5.2 is a standard deviation. So now from here, since your x bar is still normally distributed, means that now we need to standardize it to get the probability. So therefore, z is greater than 63.5808 minus 62.7 over square root of this variance. So I will take square root of, this one without square root because the n is 100. Right? So I will write 5.2 squared over 100. Then this is going to be PZ more than 1.694. So when more than 1.694, you can just refer to the graph. Symmetrical at origin. This is 1.694. To get more than, the region is towards right side. So obviously, it is found using total probabilities 1 minus PZ less than 1.694. So here it will be 1 minus PZ less than 1.694. Then here I will be getting 1 minus 0.9549. And at last, you will be getting 0.0451. So that is the probability of this type 2 error. Okay, so with this question, I have completed the whole paper. Alright, so thanks for watching. Please subscribe to the channel and share this channel with your friends if you enjoy watching my video. And also stay tuned for more upcoming videos. Thank you everyone. Bye.